Hey guys, today we're going to understand the position of the elements in the modern periodic table. Now, for that, one of the theories that we have learned while studying about the theories about the periodic table, we need to revisit that once. Now, if you remember, John Newland, he proposed a theory about the octaves and he compared the periodicity to these octaves of music. So, this guy, he had his theory rejected, but it was only years later that people could understand the importance of this and can actually be seen in the periodic table, and rather in the modern periodic table. Now, if you remember, Mendeleev suggested that these should be grouped according to their reactivity. Now, reactivity depends upon something that we call as the electrons. Now, the number of electrons you have in the valence shell is what will govern the reactivity of the element. Now, let's just have a look at the alkaline metals. They have one electron in the valence shell, and hence they readily give it away and react with the halogen group, which readily accept one electron and form a compound. So if you just take a close look at the periodic table, you would understand that the elements in the first group have one electron in the valence shell, whereas the elements in the second group have two electrons in the valence shell. In the 13 have 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and our very own 18th group of the noble gas has 8 elements in the valence shell. Now, if you remember, you have studied the maximum number of electrons which any orbit accommodate. Now, if you remember this, there was a formula 2n squared, where n was the orbit number and which had to be squared and had to be multiplied by 2 so as to know the number of electrons which can be accommodated. In the K shell, you have barely 2 electrons because K is the first orbit, so 2 times 1 square is 2. In the L shell, you have 8 electrons because 2 times 2 square is 8. Then in the M orbit, you have 18 electrons as you have 2 times 3 square, which gives you 18. So now let's just look at a few elements from various groups. Now, the first element in the first group after hydrogen, lithium, with 3 electrons. Now, the electronic configuration is 2 and 1, with 2 electrons in the K shell and 1 electron in the L shell. Now, just after lithium, you have sodium in the same group. So, electronic configuration of sodium is 281. Now, if you look at it carefully, you have 1 electron in the last shell, but the last shell is now no more the L shell, it is the M shell. Similarly, with beryllium in the second group, you have the electronic configuration of 2, 2, 2 in K and 2 in L. For magnesium, you have 2 in the first shell, 8 in the second, and 2 in the valence shell. Again, the last shell over here is the M shell. Let's go to the other side of the periodic table in the halogen group. Let's talk about fluorine over there. Fluorine has 9 electrons. So the electron configuration is 2 and 7. 7 electrons in the valence shell. The valence shell over here is N. And let's compare it to chlorine, which is just after fluorine in the same group. It has 17 electrons. The electron configuration therefore is 287, which means you have 7 electrons in the valence shell, but the valence shell now is the M shell. Now, you need to keep this in mind, as the next topic that we're going to study about are the periodic trends, and this is going to come handy to you over there.